one more partial derivative calculation problem. Let me show this here. So we have this equation here with x and y and z in it. And so this is going to be, we're going to think of z as implicitly defined as a function of x and y through this equation here. So find the derivative of z, the partial derivative of z with respect to x here. And so once again, we're going to do find this partial derivative. So remember back to doing implicit differentiation in Calc 1, where you have like an equation with x's and y's in it, and you say the equation is implicitly defining y as a function of x. Well, here we're going to have z implicitly defined as a function of x and y. So what we're going to do then is, just like we would do in Calculus 1, we're going to take the derivative with respect to x of both sides. But now this, it's a partial derivative, not just a normal d by dx, but the partial derivative with respect to x. Okay, and so let's see what we have here. So the first thing is that we have the derivative with respect to x of y times z. We're going to once again think of y as a constant here. So the derivative of constant times z with respect to x is just going to be y times dz dx. Then the next term is going to be the derivative of natural log of z with respect to x. And so that's going to be the derivative of natural log of z is 1 over z, but then we also have to multiply by the partial derivative of z with respect to x. On the right side of the equation, the partial derivative with respect to x of x is just 1, and the partial derivative with respect to x of y is 0. So this is the equation that we end up with. And then just as back in Calculus 1, we're going to factor out dz by dx times y minus 1 over z is equal to 1. Dz, partial derivative of z with respect to x, times all of this. So dz dx will equal 1 over y minus 1 over z. And so this is our final answer. We can rearrange it if we want to, but this serves as a perfectly good final answer. Okay, so we've just crunched through 3 videos all about how to compute partial derivatives. And so I think it's a good time for a pre-class problem here, something for you to work out here. Let f of xy is log of x squared plus y cubed. Compute the 2 partial derivatives.